Hello, and welcome or welcome back to Inclusive Design 24, our 2025 edition. Uh, this is brought to you in partnership with our Platinum supporters, Accessibility Cloud and Intopia. If you do the social media thing, you can follow us on Mastodon, LinkedIn, and Blue Sky. If you have questions for our presenter during at this talk, you can post them on those social media accounts using ID24 hashtag, or you can also use the YouTube chat feature. We'll be monitoring both to gather your questions for the end of the session. And as a reminder, Inclusive Design 24 is a respectful community, and you can find our code of conduct on the Inclusive Design 24 website. And now I am absolutely thrilled to introduce our guest host, Mr. Jared Smith. Jared, over to you.
Thanks, Eric. Yeah, and welcome everyone. We're thrilled for our next speaker. Jonathan Zong will be presenting accessible data visualization for screen reader users. Jonathan, over to you.
Thank you so much, Jared. My name is Jonathan. I'm a professor at the University of Colorado Boulder in the Information Science Department. I'm super excited to be here with you all on the internet today to talk a bit about my group's work on accessible data visualization for screen reader users. Um, so I lead a group at CU Boulder called the Data and Design Group, and we're a research lab that does kind of prototyping and speculative co-design with blind and low vision collaborators. Um, and so we're really thinking about kind of doing that exploratory work, talking to people, doing research to understand needs and think about how we could be, doing accessible data visualization better. And so this talk is kind of about, sharing some of that exploratory work and research and design work that we've been doing. I just want to be clear that it's not about, it's not like a how-to on how to comply with existing visualization guidelines. So some of this work is going to be kind of about lessons learned. Some of it's about like some of the prototyping that we did. And we really try to approach this with, curiosity and humility and kind of the understanding that, we might not know the best way to do things, but we're trying to kind of constantly improve. And so, I started this group at CU Boulder, and my background is kind of in data visualization and human-computer interaction. I did my PhD fairly recently at MIT, and my dissertation work was on design and accessibility. And I want to also acknowledge one of my close collaborators on all of this work, who's not on the call with us today, but Daniel Hayesh, um, who is an innovation manager at the Global Disability Innovation Hub. And Daniel is blind and has a background in physics and informatics and has also worked on kind of the design of assistive technology. And so a lot of the work that I'll be talking about today is a collaboration with Daniel and also some of my former colleagues at MIT. So just to give a bit of background, the National Federation of the Blinds did some survey work and found that there's over 7 million people in the United States alone with some form of visual disability and more worldwide. Uh, and despite kind of such a large population of people, uh, other work kind of auditing the accessibility of pages on the internet found that 96.8% of the top million pages on the internet kind of fail to meet basic accessibility standards that are supporting screen reader users and getting access to information. Um, and I think many in the audience are likely, have encountered screen readers before or maybe use screen readers. But just so we're on the same page, a screen reader is an assistive technology that, often you're controlling with like swipe gestures on a touch screen or with a keyboard, arrow keys on a keyboard. And there's a cursor that highlights elements on the screen and reads them aloud as text to speech. But when you think about kind of the average experience of using a screen reader for specifically data visualization, the experience is something like this.
Image, 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 image. One face. Image. Logo other. Image.
And so that was an example of trying to navigate a map of election results. And that video's been shared online by Sarah Fossheim, who's an accessibility expert. And so this is a really far from ideal experience. And so a lot of the work that I've been doing with my collaborators is thinking about this question of like, how do we make, charts and graphs and things like that more accessible for screen reader users? And part of the challenge, like the reason why this might be hard, is this idea of needing to design for modality differences. So, visualizations have these visual features that sighted readers are kind of shifting their attention to on the fly. You can kind of focus your attention on different parts of a chart, get like overviews, get zoom into the details, just kind of shifting your perception at will. And screen readers kind of, because you're navigating them in this linear predefined reading order, kind of impose some constraints on the way that, you're able to explore information sometimes. And these are kind of differences between, the visual modality and maybe the auditory or the, keyboard interactive modality. And so when we think about current best practices in how people are trying to make charts and graphs more accessible, I think there's two main approaches that have been highly recommended. So one is, of course, alt text or alternative text, and that's where you describe the content um, of a chart or a graph or a map. Um, and so, for example, that video that I showed of the election map, and alt text for that might be something like map of 2020 US presidential election results. Joe Biden has 227 electoral votes. Donald Trump has 213 electoral votes. 98 votes remain. And then the second best practice is that it's highly recommended to always include access to the original data table that goes with the chart. So on the right side of the screen, I have that example data table that might correspond to that map. And when we think about kind of some of the drawbacks of these best practices, right? With alt text, you have kind of a single static interface. So whatever is written in there is kind of what you get, and you're not able to kind of adjust the description, right? And as a result, there's this limitation where you kind of don't really have control over information granularity. So with that alt text, I know, maybe how many electoral votes a candidate has, but if I wanted to break that number apart by different states, right? I could do that with the map visually, but that would be really hard with just that alt text. And then on the other hand, the data table kind of addresses some of that, limitation with the alt text where, you can navigate around it. It's maybe more granular, right? You can get different rows that are kind of broken down by state. But it's very tedious and time consuming, right? This table might have hundreds and hundreds of rows. And for someone who has to kind of listen to all these in sequence, it can get very tiresome. And finally, with tables, it's difficult to understand high-level patterns, right? So part of the value of a data visualization is the fact that, it's not just kind of mapping the table to a visual, but we're kind of leveraging parts of visual perception to kind of make it easier to understand certain aspects of the data based on kind of the design choices we're making. And so there's really this like higher level like storytelling aspect that is missing from the data table. So I think because of these limitations of these best practices, there's a lot of consequences for blind user agency. When we talk to folks about their experiences with data visualization, people said, we're at the mercy of all text writers who make assumptions about what data I'll be interested in. Someone said, well, sorry. Someone else said, it's hard to do your own analysis and be given a text description that you just have to trust, right? So there's that idea that there's dependence on the sighted people who are kind of interpreting the data for them. And then finally, some people just said, I'm kind of desperate for anything I can use. There's not a lot of tools that kind of address these problems. So we put together a team and we did this project around, thinking about the design dimensions of what might be richer screen reader experiences for visualization. And this is a research project that we presented a few years ago at the Euroviz conference, which is a major conference in the visualization community. And it was recognized with the best paper honorable mention. So I'm kind of glad to see that, the community in visualization is agreeing that this is kind of an important problem, right? And I'll say a bit more about what I mean by design dimensions, but I'll start by showing a video of some of the prototyping that went into this project.
Let's say I'm using a screen reader and I encounter the scatter plot on a page. With Ollie, at first I'll hear an overall description of what the scatter plot is.
A scatter plot with axes flipper length, mm, and body mass, g.
Let's say I want more detail about the scatter plot, so I can press the down arrow key and expand this structure to the next level where I can get information about the different axes and legends of the chart.
X-axis titled flipper length, mm, for a quantitative scale, with values from 172 to 231.
And once I'm on this level, I can press the left and right arrow keys to cycle through the other elements on this level.
Y-axis titled body mass, g, for legend titled species, for an...
Let's say that I'm interested in getting more detail about the x-axis, so I can navigate back over to the x-axis with the left arrow key and then press down again to descend into a further level of detail.
Y-axis titled, x-axis titled...
Now down arrow to expand.
1 of 7, flipper length, mm, is between 172 and 180, 7 values. Press T to open table.
And on this level, I get information about the intervals along each axis.
2 of 7, flipper length, mm, is between 180 and 190, 3 of 7, flip 4 of 7, 5 of 7, 6 of 7, 7 of 7.
So just to say a bit more about what I just showed, right? This is a video of a prototype interface for using a screen reader to explore around a scatter plot that had data about, different penguins. And, there were multiple levels in this interface. So you could kind of, with your arrow key, move up and down different levels. So you were at the top level, you got like a general overview. Then on the second level, you got different axes and legends, and you could use the arrow keys to kind of move side to side on that level. And then you could break down the axis into different, ranges along the axis, and it would tell you how many values were kind of between those two values. So maybe like, 38 values between 200 and 210 for flipper length. And finally, you could open a data table to get that conventional tabular representation of the data that you were focusing on. So I just want to kind of point out a few differences from some prior screen reader interfaces that we thought were significant when we were exploring this way of doing things. And one of those differences is hierarchical structure, right? So, a lot of conventional screen reader interfaces have a very linear or flat structure where you're just kind of going forward and back between different things. And especially on a data visualization where, like we were saying, a lot of the reading process for sighted readers of visualizations is kind of breaking down these values and kind of going from overview to detail. We thought having a hierarchical navigation structure would kind of address some of that need. And similarly, giving control over navigation, right? So we really wanted people to be able to kind of do some self-guided navigation around this hierarchical structure and have control at each step over, whether they wanted to move up or down levels, move around in the same level, or, drill down for more detail. And finally, this interface had multiple descriptions at varied levels of information granularity. So as opposed to just a single alt text that kind of tries to, have the overview and the detail, but it might get really long and take a long time to listen to, we decided to have multiple shorter descriptions that you could kind of control and give some of that effect of being able to, get high-level patterns and break those patterns down. So I introduced this project by saying that our goal was kind of to think about design dimensions, right? And what I mean by design dimensions is like, what are some considerations or what are some like features of, this type of interface that designers should be thinking about when they're making these interfaces for screen readers. So we were trying to think about, what were some considerations that like other designers could take away from what we did and apply to their own work. And we came up with these three design dimensions of structure, navigation, and description. And I'm just going to talk about these kind of one at a time, starting with structure. So when I say structure, I kind of mean the way that a screen reader interface organizes the data and visual elements of a chart into a format that can be traversed by a screen reader. And so when we were looking around at, how other maybe like visualization libraries were approaching accessibility, right? We saw a lot of linear structures, um, kind of uh, applying, alt text, for example, to different elements of an SVG. And the drawback of this is like, maybe you have like a summary alt text and then you have a description of the x-axis, and then you press next and you can go to the description of the y-axis. And then once you get to the data points, a scatter plot like that penguin scatter plot I was showing might have like 500 different data points, right? And so if you have a linear structure, then you're kind of hitting next through maybe 500 individual data points, right? And um, that's not really helpful for kind of building up a picture of how that chart's organized. Um, and so, there's other possible types of structures, but as I was saying with that prototype, we were kind of exploring hierarchical, kind of like tree-like structures, where you have the summary at the top, and then you can drop down a level, get the different axes and legends, drop down another level, get, intervals and categories, and then finally at the bottom, like most detailed level, get the individual data points. So that's an example of structure. Next, I'll talk about navigation. This is our second design dimension. So with the idea of navigation, we wanted to give different ways to navigate, right? Different options for navigation that might be suitable for different use cases, different tasks. And so what I was demonstrating in that video prototype was what we're calling structural navigation. So this is just moving along the structure, right? Like up and down arrow keys to go up and down different levels of the structure, and then left and right arrow keys to move around along the same level, like between different axes or different intervals. But there's also other options, right? So some of the other things we explored include spatial navigation. So this is moving around in kind of XY screen coordinates instead of around the structure. So for a scatter plot, maybe the up arrow would be towards the top of the chart rather than upwards in level of detail, if that makes sense. And then finally, the third option we came up with was this idea of targeted navigation. So this is the idea of jumping directly to a known location. So maybe you have like a certain range of the data that you already know that you're interested in, and you want to go straight there. And like if you did structural navigation, it would just kind of add a lot of like steps of, figuring out which arrow keys to press to like get there and finding the path and stuff like that. So with targeted navigation, we prototyped some menus where you could just kind of directly jump to known places on the hierarchy and then explore around locally from there. And then finally, description. So with description, we were kind of trying to break down this idea of like what goes into a description into a couple more, you know, uh, into a couple more properties. So we kind of broke description down into content, composition, and verbosity. And so by content, we were thinking about like what is the semantic content that is going into um, a description of a chart, and like how like high or low level is it, right? So you could have very low level things being described, like what is the chart type, what are the labels, what are the axis ranges, what are the colors, right? Um, you could have slightly higher level things like descriptive statistics, like, what's the average? You could have things like outliers, correlations, and stuff. And then once you get to even higher level, like you start getting into things that might be like, specific to a person or maybe culturally and contextually specific. So that's things like higher level patterns, if you're referencing, uh, commonplace concepts or, like things like um, different penguin species and stuff that you might expect, there might be differences in, prior background. And then finally, at the highest level, maybe there's like, yeah, domain-specific insights, or maybe you're referencing current events or like social and political context. And this is stuff that is maybe, harder to automatically generate. Um, but, deciding at what level to describe something, what to include, what's not relevant, that's all thinking that goes into making a description. So that was content. Moving on to composition. Um, Maybe another way of saying this is like ordering. We were thinking about like, when you're building a description, because someone is listening to it from start to finish, and a lot of screen reader users, are really looking for the information that they need that's relevant to them, and then they want to kind of like move on to the next thing, right? Um, we were thinking about, different use cases for a chart. Like if you're looking at a chart and it really matters to you, you're finding things with a specific category, then maybe you want category to be earlier in the description. But if you're looking for, I want the third data point, then like, something like 0.3 of 10, that might be really important to be closer to the front, right? And so there's no like right answer for this, but it really depends on, what the user is trying to do, what the reader of the visualization is trying to do. Um, and we did some follow-up work on this that didn't make it into this talk that was around, enabling users to kind of customize the ordering and things like this and actually change how descriptions were assembled based on what they were trying to do. And then finally, we were thinking about this idea of verbosity. Um, and there's like verbosity settings in screen readers that are configurable by the user, but they're usually about things like, do we include the punctuation or not, or do we like include, certain metadata. Um, Here we're thinking about verbosity in the context of the description itself, where like you could, for someone who hasn't really encountered this specific chart, for example, before, like you could have a description that says interval with 6 values in the range 20 to 30. But if someone's really familiar with this interface and kind of just wants the numbers, the description could just be 6 values, 20 to 30, and they would kind of already know what those numbers meant. So here's an example gallery of, some of when we were doing our exploratory work, some of the different types of charts that we were able to support using this kind of approach with the hierarchical structure and all of that. We thought about like different faceted charts, we thought about maps, we thought about like stacked bars. So just to say that we kind of um, tried to think about how this would apply to different scenarios. And I'm pretty pleased to say that I think has had this type of thinking has had a relatively um, successful form of impact in the visualization community, which is that, I think we're really shifting the way researchers are thinking about accessibility in visualization. So, since we presented this research for the first time, there have been different researchers at places like CMU, Microsoft, MathWorks, Tableau, and they're all kind of building on our thinking to design more accessible interfaces in their own context, which I think is really exciting because I think it's really a team effort to make these things accessible. And another form of impact that I've been really happy about is just kind of contributing to public conversations, right? Like building awareness that data visualization is like an important area for accessibility that like we all want to be thinking more about, right? And especially, conversations about making STEM fields and science careers more accessible have been really exciting for me as an educator. And finally, we've released some of our prototypes as an open source library called Olli. That's OLLI. And the URL for that is our lab website is data-and-design.org, and you go to /project/Olli, OLLI, and you can find out more about code that people can try to include on their websites to present these data visualizations like this. And so, like I said, I'm really like proud of the progress we made on this project, right? But I want to be clear that there's still a lot more to think about, right? So as we were kind of conducting follow-up work, we were talking more with blind and low vision professionals who use data a lot in their day-to-day lives. We were hearing people say things that we found really interesting. We were asking people about like why it mattered to them that data visualizations were accessible, right? And people said things like, I want to participate meaningfully in a discussion at work and not seem clueless. They also said things like, as the only blind person on a team, consistently being the only person who can't comment, like, might affect promotions and work opportunities. And one person was like, am I really going to depend on my collaborators to do all the analysis all the time? Or, am I going to keep trying to find ways to do it myself? Um, and this really, raised this question for our team around like participation and power, right? Like, is getting access to charts that other people are creating enough? Like, are we kind of um, you know, even if we're thinking about making existing charts accessible, are we kind of perpetuating this idea that like sighted people are like the ones making the charts, and then the blind and low vision people are just the ones accessing them, right? Um, and so we kind of shifted our focus a little bit for the next project around this question of like, how do we empower screen reader users to create their own interactive data representations? And part of the challenge here, or some of the problems we encountered when we were looking around, is that a lot of existing authoring tools kind of implicitly center visual specification, right? Um, and I have some examples here of like tools that I think are really great, right? And they're really useful, and lots of people get a lot of value on them. So I'm not meaning to kind of disparage the work that these other teams have done, but I was noticing this pattern of, existing tools kind of either requiring an existing visualization to convert into a non-visual format, or, maybe you can make a sonification directly, but you have to do it in terms of a chart. So like you say what's on the y-axis and what's on the x-axis, and then you get, the non-visual representation. So this translation first into the visual to get the non-visual thing was also kind of part of what I was thinking about as like centering visual specification. Um, and I think this has a few consequences, right? This idea of visual centrism in authoring tools. One is that, like I was saying, blind and low vision users kind of have to specify their intended non-visual designs in visual terms. And in the field of human computer interaction, I'm an academic, so I'm always kind of referencing these ideas, but we have this idea of the gulf of execution, which is kind of the distance between like the idea a user has in their head of what they're trying to do, and like how they translate that into like an action that they can execute in the interface. And I think doing this kind of like translation into visual vocabulary for blind and low vision people is adding that extra step in being able to kind of do what they're trying to do. And then the second point I'm trying to make here is that not all non-visual designs have an equivalent kind of visualization, right? And so there's a sense in which if we only think about translating visual charts into, non-visual things like descriptions and sonifications and stuff, we're actually limiting the expressivity, or like the possible like range of what people are able to create, right? And so just as a few examples, like I think, a lot of existing sonification tools have a pretty limited range of visualizations that they're able to support. And that's because, sonifications are kind of played sequentially. So logically, there's like, um, it's a lot, more obvious how you would kind of translate like a line chart of like a stocks thing or like the weather than for some other types of visualizations. And then, for some other libraries, there's a lot of types of charts that, um, are documented to be like, you can describe these with our tool, but you can't explore them using sonification. And I think that kind of artificial limitation is based on this need to kind of like translate directly between visualization um, into other forms. So our approach here with the project we did was to kind of try to design an accessible authoring tool for creating some of these data representations that decenters the visual modality. And this is a project called Umwelt, UMWELT, that we presented last year at some human-computer interaction research venues. So Umwelt is this editor it's a web-based tool that we've uh, made available online that's for authoring multimodal data representations that include visualization, they include sonification, and they include that type of navigable text description that I was talking about previously. So it's this interface, there's like an editor on the left and a viewer on the right. And you can make changes in the editor with these kind of standard HTML elements that are very, screen reader usable. And you can upload a data set and you can choose the fields in the data set that you're trying to use, and then you can kind of define mappings between those fields and different uh, properties. So very similar to a lot of visualization editors, but uh, you can uh, use these field mappings to also define non-visual relationships as well. And so I'll just walk through an example of like, how you might create something with this. Um, and hopefully try to make the case that, what we've done here is we've like decoupled the authoring of different modalities so that you no longer have to like make a visualization first to make the other things. So for example, we upload that penguins data set from earlier. You get this list of fields that are in the data set. And by default, without having done anything, you just get the textual output. And where before we had the textual structures that we're talking about, like, oh, this is a scatter plot, these are the axes. Since there's no kind of visual mapping yet, the default textual description just says, hey, this is a data set with 7 fields. These are the different fields, and you can group by them to kind of explore. So already there's like a textual description that is not using like visualization specific language. And then so let's say you want to focus on the beak length field in the penguins data set. You can uncheck all the other fields, and then the textual description will update based on what you just did to kind of show you, just the data grouped by beak length, and it'll kind of break it down into different intervals. So like, there's 8 penguins that have a beak length between, 32.10 and 35. So now, let's say we want to make a sonification of that, right? So I can go elsewhere in the editor and go under beak length, and I can add an encoding, which kind of is just a mapping of that field to some property, and I can choose the volume property. And once I do that, a set of audio controls appears next to the textual description that kind of has a default output. It's grouping the beak length and it's mapping the count of penguins with beak lengths in those ranges to the volume of the playback. So I'll just play that now to give a sense of how that sounds.
30, 35, 40, 45, 50, 55.
So there, like a louder tone meant, there was more penguins that had that approximate beak length. And so, just to point out, we've created the sonification. We haven't even had to think about visualization yet, which was one of the things we were trying to accomplish, right? We don't have to translate things into visualization to get something like a sonification. But let's say we do want a visualization to kind of accompany this sonification, right? And that might be important, if you're making a presentation and a lot of your audience is cited, right? You still want to be able to have that option. So I could go to beak length, I can add an x-axis encoding, I can add another field for species and maybe map that to color. And then now I have that visualization that I just defined appearing next to the other 2 representations. And now that there is a visualization, the textual description can kind of automatically update. And now it says it's a point chart. Here's the x-axis, here's the legend. But we didn't have to have that visualization before to have a textual description. Cool. And then the last example I'll kind of walk through with this tool is this idea of like getting more expressivity from diverging modalities, right? If you kind of don't assume that the sonification has to be doing the exact same thing as the visualization, right? Because we're in this multimodal setting where there's also a description, um, it means that each representation doesn't have to do like the entire job, right? And we can use them in complementary ways. Um, so I'll show this example sonification that is accompanying a scatter plot uh, based on that previous example data set. Um, and this is a sonification where it's kind of going along each of the axes and it's mapping the pitch to the average of either the flipper length value or the average body mass value for the x and the y axes respectively.
2,700, 3,000, 4,000, 5,000, 6,000, 170, 180, 190, 200, 210, 220, 230.
And the point I'm trying to make here is that so this sonification isn't exactly the same thing as the visualization, right? The sonification is binned, so it's grouping different ranges of flipper length and body mass, while the visualization is not. And if you actually took this sonification and turned them back into visualizations, they would actually look more like these two bar charts that have that binning. So the point I'm trying to make here is that if we embrace this idea of designing for complementary use, and we have multiple modalities where no single modality has to completely replace the visualization, we can design things like this sonification that serve specific tasks, right? This sonification is really good at conveying a distribution along each axis. And if you need to get individual data points, you can just use the textual description and have those read out as well. So again, here's an example gallery of kind of different types of representations that we've used Umwelt to create. And this is also findable on our website, which is data-and-design.org. So that brings me to the end of my talk. I hope you've found this work interesting, and I'm definitely always open to chatting with more people who have been thinking deeply about how to make data more accessible and communicate with data. And this is something that we're actively building our work around here at CU Boulder. So please do feel free to reach out to me by email or social media. But thank you so much, and I think we'll have some Q&A now.
Thank you, Jonathan. That was a really great talk. Jared, do we have any questions for Jonathan?
Yeah, there have been a few questions. Thank you, Jonathan, as well. Yeah, wonderful, wonderful, very interesting presentation. We had a question about just your processes for approaching some of the structures that you had, for instance, content, composition, and verbosity, which I think is a really interesting way to break down some of these content and structure pieces. But we're just wondering, how did you come up with those, and if there were any roadblocks or discoveries along the way, and maybe how maybe users with disabilities may have informed some of those processes.
Absolutely, yeah. Yeah, our process, I really have to, shout out my collaborator Daniel here. So this project happened over the course of like a year, and we spent, I think, something like 9 months just doing this iterative co-design process where you know, we would kind of like have Zoom meetings every single week. Daniel, who's blind, would be, in the room with us, and he's had experience, designing assistive technology, but he's not necessarily a visualization expert, right? And then we had other people on the team who were visualization experts, but didn't have that lived experience of being blind and using a screen reader on a regular basis. So we were all brainstorming together on different approaches we would try, and some of us would go and then, implement some quick prototypes in JavaScript where you could kind of just, you know, click around and it would be kind of a toy example, right? Uh, And then we would send them to Daniel, and Daniel like is so amazing and would just send back these really long emails with all these like really deep observations about, what was working well, what didn't, and then we would all kind of come back together and discuss them over Zoom and then kind of repeat the process, right? Take what we learned and then go make more prototypes and do that. And we did this for a really long time. And that's kind of how we kind of settled on some of these like concepts like, content composition and verbosity is we had this like rich body of like Daniel's notes, our like discussions over Zoom, all these prototypes, and we kind of looked at them and kind of looked for kind of common themes or like common challenges we were running into, and then tried to like distill all that experience into something that would be useful for other people. And then at the end of our, prototyping process, we had a couple that we thought were like doing the best. And then we did kind of a more, a study that then brought in more blind and low vision participants where, we sat down with people over Zoom for about an hour. We had them try different prototypes. We kind of taught them a little about, our ideas about navigation, and then we got feedback, right? And then that then even yielded, more insights that then were kind of all written up in our research report that then we presented at Euroviz. So that's available online too, if people are interested in reading more, especially, some of the insights from our studies.
Yeah, thank you. Another question. This one's about AI. What possibilities do you see for blind users getting the information they need from an otherwise inaccessible graph through targeted questions to an AI model? I think AI has capabilities to do, at least potential to do a lot of these types of things. And you pointed out the general inaccessibility of the web, and of course, complex data visualizations are definitely part of that. But do you see AI as maybe as an end user tool to maybe make some of that content more accessible?
Mhm. Yeah, thank you for this question. I think this is a really exciting question and something that we're all kind of collectively trying to figure out as, things are changing so quickly. My take is like I see a lot of potential in AI, and there's certainly been projects that I've been excited about pursuing. So, there was a student in my previous lab who did a project around, embedding LLM calls into some of those like hierarchical structures, right? Where then it could try to bring in some of that outside domain expertise. So, if you're exploring that penguins data set, it could tell you more about like, you know, where these penguins live, like what you should kind of expect for like, the body mass or like flipper length, like is that number a lot or a little, things like that. And I think stuff like that's really exciting. Um, I also, on the other hand, think that we shouldn't kind of like consider AI as like this magic bullet that will like magically solve accessibility, right? So I have another talk that I give that has this example of like this company that got sued because they were offering this like AI accessibility tool that was like a plugin that, oh, you can just drop it into your website and it'll like make it accessible. And blind and low vision users were like suing because often the AI would just like make it even less usable than it was to begin with, right? And there's a lot of issues around AI around it. It's biased. Like there's Cindy Bennett, a blind researcher at Google, who I really admire, has done work around like, the way that disabled people are like represented within AI, and it's not always, sometimes it like reinforces some really negative stereotypes, right? The information it gives you like can be wrong sometimes, so there needs to be ways to like verify it. So I think these are just like kind of things that we have to be really careful about navigating as we do some of this exploratory thinking. But I think it's a really good opportunity for like for researchers like myself, and for anyone really to kind of like yeah, try to imagine what's possible and then like kind of go from there, right?
Yeah, thank you. Your focus here is for screen reader users, and very often the focus there becomes on users with visual disabilities. But were there any considerations for users with cognitive and learning disabilities that often use screen readers as an assistive technology for them? I just wonder if there, just were any study or research or consideration there for maybe how it might make things more accessible to those with cognitive or learning disabilities, or maybe any barriers you ran into for those audiences with really complex visualizations and interaction with that underlying data.
Yeah, this is a really fantastic question. And I will admit this is something that I don't have like prior expertise in that, and we haven't yet worked with collaborators who have that type of lived experience. So it's a question I'm really interested in, but it's not something I've been able to think deeply about so far. I will say that, like for some of the blind and low vision people we were talking to, they did bring up things that kind of made me think in this direction. So like someone was saying, oh, like I'm low vision, so I can use charts, but like I get really tired when I try to like look at these things. So like being able to listen and have like multiple options for like ways to listen with sonification and description um, were really a way to kind of like uh, reduce some of that like difficulty of focusing, on maybe magnified versions of visualizations. But yes, it's definitely something I'd like to think more about.
Okay, thank you. One more question. This is really a little more personal for you. I'm always curious how brilliant people like you land in the accessibility field, and you shared a little bit of your history and background, but I'm just curious your path that brought you to accessibility.
Absolutely. Yeah. I started my PhD, my grad school program doing pretty like conventional visualization work where I was building, interactive tools for like creating fancy visualizations. And I think it was really like my relationships with the people around me and like being in the right place at the right time that kind of got me thinking more about accessibility. So, it was a couple things like I had colleagues in my lab who like had more kind of like people in their lives who had disabilities. It was around like 2020 and COVID when we started this project where we were thinking about, so much like really important information about public health is kind of going out as these charts, like flatten the curve and all of that. And this is really just like excluding a lot of people. And getting to meet my collaborator Daniel and my relationship with him. I mean, I just really love working with him, and I've learned so much from him about, the experience of being blind, and that not just being, um, like not thinking about that just in terms of like a medical condition, but as being like an identity and like a culture and a community that you can embrace, right? So yeah, I really credit the people around me for kind of helping me learn more. And so I think, that relational aspect is really important to the work that we do.
Great. Thank you, Jonathan. We're glad that you're here. We're glad that you're part of the accessibility community, and appreciate your wonderful presentation and all of the work that you're doing on this really interesting and impactful project. So thank you for being here.
Thank you. Thank you so much.
Thank you very much for that. That's really great talk and some interesting questions as well. Thank you, Jared. Thank you, Jonathan. If you like this session, please hit the YouTube like button, and don't forget you can subscribe to our channel to be kept in the loop on any of our future events. Inclusive Design 24 is brought to you with the thanks to our Platinum supporters, Accessibility Cloud and Intopia, our Silver supporters, Intuit, and our Bronze supporters, the Law Office of Laney Feingold, Mantis & Co. and Vispero. We will be back on the hour with our next session, so we hope to see you then.